Okay, welcome again to yet another fabulous installment of recording myself doing coding challenges and posting it on YouTube. All right, so let's try a moderate one here. No, let's try a hard one. From Cracking the Coding interview by Gail Lockman McDowell. Okay. Suppose I should put a bookmark in here. Like 186. This is what you get when you do it live. Okay. Circus Tower. A circus is designing a tower routine consisting of people standing atop one another's shoulders. For practical and aesthetic reasons, each person must be both shorter and lighter than the person below him or her. Given the heights and weights of each person, the circus writer a method to compute the largest possible number of people in such a tower. So that's like an example. Input is a bunch of people, heights and weights. The output would be the longest tower. Basically, it'd be the longest decreasing longest decreasing heights and decreasing weights. The max of decreasing heights and decreasing weights. Okay, that's a good one. So I'll let you look here at the example while I'm thinking about it here. I guess that's backwards. No? I don't know how to do the video right. It's a good one though. So it's really every combination of decreasing weights, and whichever one has the highest height. So it's like a knapsack problem. Let's talk about the brute force. Okay, let's write out the brute force here. Sticky note. See here if I can change the resolution of my sticky notes. No. Let's try Word. The font of Share Word. And just like a huge font or something. And a view of like, I don't know, can I zoom in here? Yeah. That. Maybe to get to this a little faster next time. So, yeah, maybe a little bit bigger. So we have this is really a weight and value, right? So like let's call it weight and height. I'll put in their example here, a few numbers from it. 65, 100. This is weird to look at. 70, 150. And let's put one more in, 5690. So the brute force again would be, we get every combination, we sort it by weight and really every subsequence, and whichever one has the highest height. Let's think about some of the implications in this too. To say it another way, the longest, furthest right subsequence. And that's would be sorted by weight. So let's order these here to help us think about it. It has to be in order of weight. This guy here. Now it's an order of weight. So that's really it. What's really what subsequence is the biggest? So let's look at this question again, because why wouldn't it just be the entire list? Oh, it must be shorter and lighter. Oh, okay. So now we're talking about something a little bit different. So shorter and lighter. So now we're really just cycling through and creating a new structure as a first step. To take it one more step here, which is once we sort in one, then we sort in the other. So let's put both of these. Let's do it like this. Okay, so we really need a chain. So let's think about where, so if we got this guy out, is there a place where he could fit? Or is it really just one specific subsequence? Like, you have to skip him because he's not both. Here we're talking about which one do you choose. It's better. This is, that's good. Some knapsack stuff. You're trying to maximize, but in a certain order. So I think you have to choose between these two. So let's add a dimension. Let's draw another picture here. So you're going to pick one or the other. In this case, let's make it a little bit different where this one is smaller, but it's 150. This is bigger, but it's 160. Can't do that. So you have to choose one or the other. So in this case, you'd start off choosing the first, and then you'd go and choose the second instead. So now we're getting somewhere. We'd start off with this guy here and run through everything past him. And I feel like this is n squared because you have to, of time complexity, because you have to, well, let's keep thinking here. So with this 3, what's the best? I mean, 56 and 90, you get to choose one or the other. You'd choose 160 every time because it's bigger. So you're really, you gotta bring it to 4. Let's smallen this down just a little bit. Talk about something that's, in fact, hold on. Apparently the zoom doesn't get caught in the Control Z world. So let's smallen this down here. I mean, this is way too slow, right? I mean, I need to know this, but whatever. I mean, still, I gotta start somewhere. So let's bring one more in here to make you have to make a choice. So let's just write in some more here. When you choose height, your weight starts there. So So therefore, so 5690, choose a height. Don't choose the higher height. That's where your weight starts at 65. Let's look at this in 2 dimensions. So I feel like this is 2-dimensional graph type of graph search. This would be more like a, yeah. So let's see here. Let's draw it out where we'd say 56, 65, 70. In fact, can we put a table in here? So this would be 1, 2, 3, 4 by 4 table. So with this, in fact, let me make that 5 by 5. I mean, I guess we could make this a style, right? Whatever. So here, and then we have 90, 160, 150, and X or H. Here we have 56, 65, 70, and weight in. I'm not gonna. Yeah. So, or let's call it I and J. So you have to move forward in each direction. So let's see where these are. 70s, 150. Notice how we have this ordered here. Why don't we rearrange that? It might be what we're talking about here. 60. So now we have 5690 and 65, 160 and 70, 150. So now let's talk about what this would be. We've already ordered them by weight. Yeah, this is a 2-directional ordering. So here you can go out there. I mean, you can either go to here or you can go to here. Just can't go back up. So really, we want to maximize the height, or what is it? Is it the highest number? I look at the question again. It's the largest possible number of people. So it's really as you go from left to right, which is your highest number. It's kind of like doing a I mean, I guess you could call it. Yeah, let's just keep going with that. So in which case, let's do one more here. Give ourselves a little bit of bit more room. Let's just say that this guy is here. This guy's here. In which case you could do 1, 2, 3, right? So this would be, it has to be higher though. Does it? Yeah, it has to be higher. So let's find a situation where we think this is good, but then this one has to be at the 1. Let's fill it out. So you can really only go down on the right. I always end up drawing here, but is what it is. Trying to anyway. There you go. Screen doesn't like me too. Sorry, what am I sharing here, by the way? Yeah. So you got me here, computer. Just slow. It's really just, it's the only way it can go. So it's really, okay, so here's how we can elucidate the issue here. So this is here. It's really actually not that. It's for this guy. Cell, yeah, is going to be for all these cells. That's your next option. So which of these guys do you choose? Which difference would it make? Say you have one here. And that's it. That's how you choose. You want this guy because he could then keep on going, whereas this guy would only have one here. So how do you know that you make that choice? You can go with the maxes of them all. So the max of this guy would be none. Starting with him would be the max of him, be none. Max of him would be 1. So this is like max 1 is 1. Whatever, get the drift. Max of him would be 1. Max of him would be that plus that. So that's really what I think that's the answer. So you'd start at the bottom right adding up the maxes to get to the top. So you'd iterate, and the max would be, so let's write out what this would be. So then it'd be for what is this? This is the weight. Yeah. J, let's call this J here, and I in range, let's weight. I guess it's the same distance, isn't it? Okay. Lang string, or what do we call these people? No, just people, whatever. The length of people down to, I don't know, just sun, and then going -1. I'm just gonna like variabilize these because they're always so tricky. People length. First person -1. Going down. It's not a great. For I in range. Length. First person 1. NDR I J equals this is it, yeah, we'll say here this is itself, so it's 1. This is it plus 2, it's 2, 2. This guy is going to be 3. So this guy is going to be 4. So we're really going through. So this one's then going to be 3. So you're going to say it's either if your value. So let's write out the logic here and say if you have a value of 1, then 1 plus 1 offset 1 offset 1 1. So if dr I j equals 1 plus dr plus 1 and j plus 1. This is ridiculous. Else Let's just fill it in. It's one to its right. So let's follow this through. Yeah. Goes the max of I plus 1. J and dr I j plus 1. This would be that. Hmm. Then return the end of the whole deal. Well, we want to leave zeros to the end here, so that we're saying the people length here, leave a 0 at end for the plus ones. But at the end here, you want to, we're going to say return dir 0, 0. It's going to be your max. Let's lay out what MDR is. I mean, we can fill all that in. So now let's see. Let's just see if we're on the right track, and if not, then I'll just stop. Okay, so the Gail Lockman McDowell's book says that you can only do this in time complexity 2 to the n. But what we're just talking about here is, well, it's n squared. It's a lot faster. I guess you're also creating an array, which is n squared as well. So maybe it's 2n squared, really. So this is way faster than what the coding book says you should be able to do it as. I don't know. I guess there's only one way to do it, is to test it out, which I won't do here. But I mean, I don't know. Maybe we did it way faster, but maybe I'm just don't know what I'm talking about. I guess we'll stay tuned.